Limmi's mission is to put the power of AI into every researcher's hands. The Limmi Insights platform has been designed from the ground up to make AI easy for researchers to use with no coding experience required, all while operating within a HIPAA-compliant platform that has useful tools for FDA compliance and approval. Typically, building a new commercial-grade AI model based on a scientist's hunch can take months or years. This really boils down to three main problems researchers face. The first is being able to rapidly access the data in a healthcare system, which traditionally is very difficult to do and requires database administrators or data scientists to manually pull the data from an electronic healthcare system. The second is to quickly explore that data and find trends for further investigation. And the third is the ability to use AI and machine learning to quickly find patterns in this data and make a functional model that can be deployed to the real world, where it can make a real difference in patients' lives, not just in theory or in a research paper. So let's take a look at the Limmi application. In this example, the Limmi platform is connected to a healthcare system, EHR, using Limmi's integration libraries available in our Datahub. We'll investigate the relationship between various biomarkers that have been collected from patients and the prevalence of prostate cancer. Ultimately, we want to build a model that can predict cancer risk based on these biomarkers. Well, first, we have to get the data out of an organization's healthcare system. Traditionally, this would take support and months of work from a dedicated team to extract and clean the data. But here, we can simply select the department we're interested in, put a filter in for various values, let's say PSA and age, and extract the data. The Limmi platform automatically de-identifies the data, including scrubbing patient notes, to make sure we protect patient privacy during research. So now we have the data, and we want to see what trends we can see. We go over to the Data Exploration tab to take a look at the data distributions from what we just pulled, which in this example dataset is just over 100,000 records. We can easily filter the data to look for a specific subpopulation of interest and see the trends and data adjust live in our table. Let's take a look at some of the parameters in more detail. Here you can see RS1, which is a genetic biomarker, and we'll plot the biopsy result, true is positive for cancer and false is negative for cancer, against the RS1 values. You can see the clear trend here with this particular biomarker data. But now let's move to a different data point from a patient lab. Here the data is a little less clear. We can see some trending in correlation with cancer, but it's not totally clear. So now we want to try and pull out some valuable insights from this particular data and use these markers in combination to predict prostate cancer. And this is where AI and machine learning can help. We'll now move over to the Model Training tab. Now that we've looked through the data, we can train a model to predict the outcome of a biopsy. And why is this useful? Well, we can use this along with patient data and a doctor's assessment to build risk prediction and early detection tools, ultimately leading to better patient care by finding disease earlier. So now we're on the Models tab. You can select from Limmi's preset group of models or upload your own custom algorithm if you want to customize the model training. I'm going to pick one of the preset models, and you can see that the platform allows you to view the code and modify it if you so desire. I'm going to leave it as is. Next, I'll select the inputs for the model. Let's use age, PSA, the genetic markers we looked at, and a few additional biomarkers. And the target is what I'm trying to predict, so let's pick biopsy result. Once I click Go, that model is now being trained in the Limmi cloud. Depending on the complexity of the model, this can take a couple minutes or hours. So for this demo, let's go to some example models that we trained previously. Here you can see different models being trained on different inputs: PSA and age only, genetic factors and other biomarkers, etc. And in this example, you can see that a combination of biomarkers yielded a more accurate model than just age and PSA. Because training is so easy, we can now train many models on different data sets and really hone into the most accurate model we can build, even adding custom code if a user is comfortable with this. And because all of this is done on the Limmi platform, there are records of every data extraction, data manipulation, and model version we've trained, making it easy for scientists to show their work to regulators or other collaborators once they're ready to use a model. We believe that giving these types of tools to all doctors will rapidly increase the ability to validate hypotheses that clinicians have, and ultimately lead to better quality of care faster than traditional techniques. Imagine the possibilities if every researcher in the world could train their own AI models in a few hours' time, anytime they wanted. We firmly believe that this is the future of healthcare, and putting these tools in the hands of researchers will lead to rapid innovations for patients at a pace beyond what any current platforms allow. Stay tuned for part 2 of this demo, where we show how a user can deploy their models into an EHR and real-world scenario seamlessly, monitoring the results from patients in real time. See you soon.